Hello students, in this video we have two exercise problems of chapter 7, 7.15 and 7.16. First we will check 7.15. The question is a 100 microfarad capacitor in series with 40 ohm resistance is connected to a 110 volt 60 hertz supply. What is the maximum current in the circuit? What is the time lag between the current maximum and voltage maximum? So how to start? We have capacitance value C given 100 microfarad, that is 100 into 10 raised to minus 6 farad. R value we are given 40 ohm. VRMS is available 110 volt and frequency given 60 hertz. So what is the maximum current value? Means IM we are asked to find out. What is the time lag? Delta T we are asked to find out. So just like problem 7.13, here first you will have to start with finding omega. So first find out omega, or else you can use 2 pi f wherever you encounter omega. Secondly, you can find out XC. What is XC? Capacitive reactance, which is 1 by omega C or 1 by 2 pi FC. Once we have XC, you can find out mod Z, which is under root R square plus XC square, and you can find out delta. Tan of delta is XC by R. So delta is tan inverse of XC by R. To convert it into radian, you have to multiply it with pi by 180, but you will have to convert it into radian, so don't forget it. So now I can say that I maximum is V maximum by mod Z, and if you don't have V maximum, you can multiply V RMS with root 2 divided by mod Z, and that is your answer 1. Next, as explained earlier, when you are talking about 2 pi radian phase difference, the time which you are looking at is one time period. So if you have delta phase difference, how much is the time gap? So delta T is the phase difference which you got from this calculation multiplied by time period T upon 2 pi. Now 2 pi by T is omega, and hence delta T is phase difference divided by omega, and that is your second result, second required answer. So substitute these two values and you will have two answers demanded by 7.15. Now let us look at 7.16. Here the question is, obtain the answer to A and B of previous problem if the circuit is connected to 110 volt 12 kilowatt supply. What will happen if we increase frequency? Hence explain the statement that capacitor is conductor at very high frequencies. Compare this behavior with that of capacitor in a DC circuit after steady state. So here is solution of 7.15. Now when I increase omega, what I am doing, Xc is 1 by omega C. So when omega is increased too much, you are decreasing Xc to very low value. And then the mod Z, which is under root R square plus Xc square, if X is negligible, it becomes almost like R. So capacitive reactance vanishes, and then the circuit, which is actually like this, will behave as if there is no capacitor, because capacitive reactance is negligible. Okay, and then the current I RMS, if you are looking at, it will be Vrms by R almost. But suppose instead of this AC source, if we consider DC, then the situation will be very opposite, because in case of DC, the capacitor will not allow any charge to flow once it is fully charged, that is steady state. So initially for few millisecond or microsecond, you may see the flow of charge, but then you will not have any flow of charge. So in case of DC, there won't be any current passing through this circuit, RC circuit, but in case of AC, if you are talking about 12 kilohertz frequency, then you will see that capacitive reactance is very negligible and circuit is behaving almost like resistive circuit. So that is the solution for 7.16. Thank you.